Now the top layer. So how are we going to do the top layer? Well, we're going to pattern it exactly like Rubik's Cube, and this one gets a little bit obscure. Now, as you remember, the first step of getting the top layer is making sure that these edges are in place, which generally first means making sure that they're rotated up in the right direction. The cues that you have for rotation are, of course, the different colors that are here. Here you don't have that. You don't have different colors. So the only cue that you have is the orientation that's happening here, and it can get a little confusing. You know that everything is oriented right if both of the same colors, let's just move these centers back here so that they're right, if both of the colors are facing the opposite way, not the same way. So this would look pretty good. We have these two literally facing each other. That's what you'd want. The yellow ones facing each other, same thing with the blue. So we know that they're potentially rotated the right way. The question is, they're oriented the right way, or are they just rotated the right way? Well, taking a look at here, you can see that this looks like it's in the right position. In terms of this might be in the right position, although it's flush with the yellow one, not the blue one. And in terms of these two, they might be in the right position also. So it might be a matter of turning these around, and the way to do that is you're going to do the R, U, R-I, U, R2, U, R-I. And we remember that I think orientation is going to be the hardest thing to figure out. But just keep remembering that this is your bottom layer here. So if we're going to say that this is F, just remember this is up, this will be R over here, and L will be back here. So what I'm going to do is I'm going to rotate it around with the algorithm to do that, and let's see what happens. R, U, R-I, U, R, 2U, 1, 2, R-I. So it appears that we were correct in our assessment that these were in the right place. As an example, I'm going to take us to that step that we're at with this guy, just to see if there's any variabilities with that. Okay, so I basically got this up to the same level here, just to see if there's any variability. That's a cute little puzzle. This one obviously is the blue and the orange. So looking over here, we'll get our centers back here. What can we say in terms of its rotation? Well, this appears to be in, but you can see that these two are following each other, so one of these can't be in, so let's say this one is the bad one. Same thing with these two. One of these can't be right, but one of them are. And I'm going to say that this one is right, because this one appears to be flush with the blue one. So if that's the case, I'm going to do the algorithm to try to flip them all to the right side once I have the line. So let's see what happens. And again, the main thing is perspective. This will be F. This will be R. This will be U over here. So that's going to be F, R, U, R, I, U, I, F, I. And see what happened. Well, this is in place. This is in the correct configuration, which means they're sort of on the opposite way, and this is also opposite. So it's conceivable that all of these have been flipped in the right position. They just have to be rotated, which is a conceivable situation. So now I'm just going to do the algorithm that rotates them around, using this as the R, because it's got to be just to the left of this guy. It's the equivalent of this being in place and having to rotate these guys. So I have to do the edge, the R, which is just to the right of here, which is going to be here. So R, U, R, I, U, oops, R, 2U, R, I, and we're able to put it in. So that's another situation where you might have had to have used that. So let's return back to this guy over here, remembering that this was one side here, and now we've got all of our edges flipped in. Now we move to the corners. So in this particular situation, we see that these corners are in the right place. So all they have to be is rotated in. Let's turn back to here because that was a little too simple. This is a situation, of course, where the corners aren't where they need to be. This one is. It's just rotated wrong. This one isn't, this one isn't, this one isn't. This is the step where you really have to maintain your perspective, because in this situation, you're going to be doing a U maneuver, which is up here, an R maneuver, which we're going to say is here, and also an L maneuver. But this is not L. This has to be F, so L is back here. So this is where perspectives can get a little bit skewed. So just remember, this is R and this is L. So if I'm not mistaken, this is in the right place, none of the rest is. So let's start that again. Here, this is going to be R over here, and this is going to be F. The reason why I say that is that both F and R are going to move this corner. So if this is F, this must be R over here. So in that case, this is R and this is L back here. So that's going to be forward, forward, back, back, boom, 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 boom. So this stays where it needs to be, this is where it needs to be, this is where it needs to be, and now this is where it needs to be. So the last step now is to rotate this into position, and this is really the same situation that we had here. So I'll pick it up from here. And now it's just a matter of rotating it until these come into position. So turn, yep, turn, 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 turn. All right, then we just rotate this into position and do the same thing. Turn, 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 turn. Now wait a minute, it didn't work. This is all rotated, and yet we're still skewed. What happened? This is still in the wrong place. Well, actually what happened, remember how I said these have just one color? Well, even though they have one color, they actually do have an internal organization to it, where it does want to be oriented in one particular way. If I started this puzzle out by putting like a little dot on one side, then it's going to want that dot to end up where it started. It seems like I can rotate this any direction and it's fine, but in reality it just has one direction that it really wants to be. So right angles isn't going to be good enough, which means I have to rotate these guys around as well. So what I'm going to do is I'm going to pick either one, any one of them. In this case, I'll just pick this. And I'm going to rotate it like it was rotated wrong, because even though it's one color, it doesn't function like it's one color. So same thing, we're going to move it down, down, up, up, and then I'm going to rotate it back in here. And lo and behold, now it's happy. Because even though it wants to think it's a pyramid, it still acts exactly like a cube. Let's see what happens when we do this. This one, same thing, we're going to rotate it in. Sometimes what will happen, this will be in, these two will be in, and we'll have like one that's sticking out, and it looks like an impossible parity. You just rotate it in, and then pick any one of these triangles and rotate that also. So we'll rotate this in and see what happens. Down, down, up, down, down, up, up. Okay, move this one in, turn it. It just so happened that both of these ended up in the same configuration. That was just a coincidence. Boom, 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 boom. Okay, in this particular case, it was perfectly satisfied and it got fixed. So again, keep in mind that with this very last step, these triangles, although these triangles, oh, they're triangles, these edges, even though they're monochromatic, actually do have a specific orientation, and you might find yourself in what appears to be a parity when all you have to do is rotate that around. And that's it for the two different versions of the Master Minx. Just to inform you also, the Pyramminx spent some quality time with my 2x2 and spawned this guy, which I think is called a pyramorphix. If this is a master morphix, this is a pyramorphix. What this is it shares the phenotypic look of a pyramid, but this is really just a two-layer. It operates exactly like a 2x2, where it moves from this layer and this layer. And it's exactly like a 2x2. The best way to solve this is to keep the perspective that while we were defining what are our centers, what are our edges, what are our corners, let's define what these are as well. And as you know, all 2x2s, they don't have any centers. They all have edges. So although this turns here, these are not centers like you would find on this guy. Everything here are corners, because all they have are corners and not edges. So 1, 2, 3, 4. So this is the equivalent to this little guy, and this is the equivalent to these guys. And just like that, this seems to have one color, and this is three colors. So bear in mind, these are the 1, 2, 3, 4 corners that you're going to find on a 2x2. And you can scramble them very similarly. This is actually a very fascinating version of this, because it scrambles in very interesting ways with very interesting shapes. And you may think, well, what's the challenge? It's a 2x2. Anyone can do a 2x2, but I gotta tell you, it really does skew your perspective, and it could be a little more difficult than you think, but it really isn't if you just try to translate this pyramid shape into a cube form. Alright, so let me just get it more scrambled here. Okay. So how am I going to do this? Well, the way I do a 2x2 is I first put a side in, and that's what I'm going to do. So here's an orange over here, orange and blue. So I'm going to want to put a blue here. There's a blue down here, so I'm just going to turn this in. Bear in mind, these are not centers or edges. These are corners. So got the blue here, orange here. Now I need another one of the edges that has the three colors. One of these guys, it has to have the blue and the orange. Which one would that be? Well, how about this guy here? Blue and orange. So I'm just going to roll this up here. Turn. No, it's not in yet. This particular specimen that I got doesn't exactly turn so gracefully, but that's okay. Bang. Okay. So this actually is a side. This is defined as a side, where I have all of my corners in place. So then I turn it upside down, and the way I solve 2x2 is I'm going to put one of the corners in the right position. In this case, it's obviously here. This is in the right position, so I want to flip these two. So I'm just going to do a corner swap. We know how to do corner swaps to get this guy over here and to swap these two. So that's going to be, as you recall, a 2R, U, 2R, UI, 2R. Turn it by 90 degrees, then 2R, UI, 2R, U, 2R. And that keeps this where it needs to be. It swapped those two, and lo and behold, you solved it. That was just a demonstration. That was actually the easiest of situations, but sometimes you have to move it around. Just bear in mind that it behaves exactly like a 2x2, and you'll be able to solve it. If you need further description on that, let me know, and I'll do more. But that's basically it.